Hi, good day. In this video discussion, you will be learning another skill in statistics, which is the most commonly used statistical treatment in quantitative methods or quantitative research, the chi-square test of independence. This time we will be using Microsoft Excel to make our work easier and faster. Listen carefully, follow the steps, and let us begin. Let us have a very quick review on the basic concepts of the types of variables so that we will be guided as to when are we going to use the chi-square test in our quantitative research. Okay, we know that there are two major types of variables, the categorical and numerical. Categorical, something to do with description of a thing or a person. For instance, the nominal. These are the gender. Example, categories like gender, the age, the color of your skin, the city, the different cities in Cebu, or the ordinal, something to do with the ranking, first, second, third, again ordinal ranking. Or another example, the survey questionnaire that you ask, like answerable by strongly agree, disagree, strongly disagree, very satisfactorily, unsatisfactorily, very unsatisfactorily, something like that. Those are the questions that you ask in a survey questions. Those are categorical questions, and they become quantitative data or numerical. They are quantified because you assigned scales or score per rank. Example, strongly agree 4, agree 3. Okay, those are categorical, but they are quantified. Another, numerical. From the name itself, numbers, numerical numbers. So there are two major types: the discrete, which is whole number. For instance, number of students, number of dogs at home, number of household members, number of electric fans, and so many more. Continuous has decimals like height, weight, speed of a car, like 60 kilometers per hour, something like that. Okay, or the height 6.1, weight 71 kilogram. Okay, categorical and numerical. Let us look at this picture once more. Okay, these are the study habits. One has good study habit, and the other one has a little bit messy type of a study habit. So if you were to construct a research title with this, we can say it is students' study habits and their academic performance. Try to identify which one is categorical and numerical. We say that the categorical is the students' study habits. Categorical, identifying them, describing them, while the academic performance more of like the grade. So that is numerical variables, categorical and numerical in this research title. Another, corruption rate and poverty level in the world. Corruption rate may be a numerical data, but you may use ordinal, like very corrupt, corrupt, not at all, something like that. Okay, and when you ask them survey questionnaires, poverty level, that could be in a percentage, so that could be numerical. So again, categorical versus numerical. And the last one, students' online class experiences and their academic performance. Online class experience, you may ask them, example question number 1, I am able to understand the teacher's discussion because of the online class, easier and faster. The students may answer strongly agree, disagree, strongly disagree. So still that is categorical but quantified. And their academic performance is numerical. So these variables have different scales. For instance, the class experience, online class experience, strongly agree, disagree, strongly disagree. While the academic performance could be outstanding, very satisfactory, needs improvement, beginner, something like that. So there are two variables, but these variables are divided into different categories. Take note of that. Later on, we'll know why we are talking about those things. Okay? This time we'll use the chi-square test in some research contents. Take note of the formula, that is x squared or chi-square is equal to the sum of the square of the difference of observed minus expected all over or divided by expected, where O is the observed, E is the expected frequencies. We will also be using the chi-square table and the chi-square graph depending on their degrees of freedom. Let me shift to the Microsoft Excel. Okay, so this is just a sub-statement of the problem in a research, wherein, in this case, we are trying to identify the relationship between the ICT skills and the gender. Should we say that is it male who are more better than female in the different ICT skills such as video editing, programming skills, and web designing, or is it the female? Well, in chi-square test, we cannot identify that. No, we can only identify that basing on their mean, which mean is larger than the other. But for the chi-square test of independence, we are trying to identify the independence or the dependency, or how dependent the variable 1 to the variable 2 and vice versa, how they are related to each other. Okay, can we say that there is no significant difference between gender and the ICT skills? Does it matter? Do gender matter or not in the ICT skills? Okay, so first things first, we need to tally all the data. Suppose in this example we have 30 respondents. Respondent 1 in this case prefer or said that he is better or the best in video editing skills among the 3 skills. Okay, so respondent number 1 said video editing skill, and he is a male. Okay, so again, you need to construct 2 columns, one for the first variable and second column is for the second variable. So video editing skills, he is a male, and we also have here another web designing skill, she is a female. Okay, and so on, you tally them. Okay, that's it. And the next step is to construct a table such that they are across. Okay, the columns are for the gender, while for the rows are the ICT skills. Okay, now how are we going to count? Okay, let us count how many males who are good in video editing skills. So we can count like 1, 2, 3. It will take us a lot of time, especially if we have enormous number of respondents. So what are we going to do? We're just going to use a formula here. The formula is equals count ifs. Okay, let us wait for it to. That is count ifs. Okay, ifs with S. Okay, first highlight the range number 1, all the male among these data. Okay, again, first equals, click highlight all the data of the gender, click comma. Okay, after clicking comma, click male because we are looking for the male respondents. Okay, and let us click another comma and highlight once again the data of the ICT skills, and click comma again and click video editing skills because we are looking for a male who is good in video editing skills. Let us click this. That's it. Close parenthesis, click enter. That's it. Therefore, there are 8 male and there are 8 males who are good in video editing skills. Now, how about for the programming skills? So, we are just going to drag this one, this one, double click and then drag down, drag down. That's it. But first, let us check the formula. There are are there 5 males who are good in programming skills? Okay, it so happened that we highlighted everything here. Okay, just to check, huh? Okay, this one, the blue one. Okay, this one. Okay, but we need to highlight everything here. So we really need to check. Okay, check. Hold on, huh? Okay, let us delete this first. Go back a little bit. Let us lock. Okay, lock the range. This blue one, this one, so that it will be kept on repeating for the next columns. So what you're going to do, click F4. F4 at the topmost part, this one, F4. F4. That is already locked. And the other one also, F4, the violet. Click enter. Okay, that's it. And then let us drag it down. I guess we need to lock also the M2. Lock F4. Lock F4 the L2. This one. But if you want, you can do it manually. Okay. Still 5. Okay, let us click this. Okay, so the blue one, these are the range, and then out of the male there is how many male who are good in programming skills. So it so happened that we have this programming skill here. Okay, click enter. Okay, there are 5. While for the web designing we have, okay, so let us transfer this green one because we are looking for the web designing. Okay, just move, drag, okay, and male still, since this is still male. Okay, so that's it. There are how many? There are 2 students who are good in 2 males who are good in web designing. Now let us check if it is equal to 15 because we have 15 male respondents and 15 female respondents. So just use the formula equals sum, just type it in and highlight everything. I guess this is equal to 15. Yes, this is correct. Now for the female, let us use another formula, equals, click female. No. Type the count ifs first, count ifs with the S, count ifs. Highlight the range from here, click comma, and we are looking for the female. Okay, click comma once again, and highlight the another variable, the range, the ICT skills. Highlight everything, highlight. Okay, click comma, and we are looking for video editing skills. Click that one. Click before you click enter, let us lock the range. Click F4 for this M2, this one, F4. Ayan, you have no $sign here. Another F4 for M31, F4 for L2, and F4 for L31. Click enter. That's it. There are 5 female respondents who are good in video editing skills. Let us drag now for the programming skills and check the, okay, as you can see, we have locked in the date at the range. But are we looking for the programming skills? Okay, correct. How about the web designing? Are we looking for? Okay, let us transfer this to web designing. Okay, click enter. Now there are 6 female respondents who are good in web designing. Click enter. Okay, that's it. And you can also click sum, another sum. Click sum and highlight, and to check if this is 15. Okay, that is equal to 15. Now, another next step is to construct sum. We have row sum, and also we are done with the column sum. For the row sum, click equals sum. This is just the formula, no? Equals sum. Highlight everything, click enter. Okay, that's it. And then you may drag it downwards this will yield the same formula. You may check, okay? Equals sum. Therefore, there are 30 respondents. To check, yes, there are 30 respondents. Now you have tallied it very well. Next, you are going to copy the data. Just copy the data to the next table. By the way, this is the observed table. Observed means the actual data. But what if we transfer it to the expected? Okay, our null hypothesis. We expect it to what? Okay, let us just transfer all the formula. Okay, this is already formulated. Equals sum. Now we are going to proceed to the computations now. Okay, first step is to click this one and use this formula. Row sum RR times column sum, then the product is divided by n, which is 30. So how many? Oh, again, how are you going to do this? Click equals, then the aligned here is 8, no? And you click row sum, that's 13, times, that is asterisk, times 15, enclose these with parenthesis first, and divided by 30, that is enter. That's it. So we expect 6.5, but the observed or the actual is 8. Okay, let us go to the next cell. But to make our work faster, let us lock it in to have the same or constant, let's say, formula. So just click F4 thrice for U6. Okay, thrice. 1, 2, 3. Okay, dollar sign on the first. Okay, and for the S9, click twice F4. 1, 2. Okay, that's it. And for the U9, click once F4 once. Click enter. Okay, and you may now drag it to the right, drag it to the bottom. Okay, that's it. Let us check. 4, is it really 4? Okay, because the formula here is row sum times column sum over n. That is correct. And still, kind of check if it is equal to 30. Both are equal to 30. Okay, that's it. Next, we are going to have the last table. Okay, this is now the test statistic table. We are going to use now the formula of the chi-square, which is the observed minus expected squared over expected. Okay, this is going to be easy because we have Excel with us. Let me zoom it out a little bit. Click now the male video editing skills. Click equals. Just use the formula observed minus expected. Let us use parentheses first. Observed, which is 8, minus expected 6.5, close parentheses, then squared. How to do the squared? Just click ampersand squared. Okay, enclose it with parentheses. Okay, both sides. Okay, that's it. And all over or divided by 6.5, which is the expected, no? Expected. Again, observe minus expected squared over expected. Click enter. That's it. And you may now copy, drag to the bottom too. That's it. Let us copy the formula for the sum. Just Control C and copy it here. Control V. What is the formula here? Equals sum. You can write it in. Hold on. Sum, enter. Drag it to the right. Okay, that's it. This one here, let me mark it with color orange, is now our chi-square test value. Okay, which is 2.8034. Okay. Now, let us identify the confidence level. Most of the time we use 95%. Therefore, our alpha is 0.05. Okay. Degrees of freedom is 2. Why is it 2? This time we have another degrees of freedom formula. It is row sum, the number of rows. How many rows? We have 1, 2, 3. Minus 1. No? Row minus 1. Number of rows minus 1 3 minus 1, that is 2. No, that is 2. Times number of columns. How many columns? There are 2 minus 1, 1. So 2 times 1, that is 2. Okay? That is how you use the degrees of freedom. Again, number of rows minus 1 times number of columns minus 1. Okay? That is now. And then for the chi-square test statistics, you're just going to click equals and the answer. That's it. For the critical value, you may use the chi-square table. Okay? Diba, we know that our alpha is 0.05, right? And our degrees of freedom is 2. So we will have a critical value of 5.99. Okay? Again, alpha 0.05 and degrees of freedom is 2. So that is 5.99. Okay, that's it now, 5.99. But we can also use a formula, which is the equals chi-sq with a q dot env, and then you are just going to, let me delete it first, to click the probability level, which is 95%. Okay, let me delete it. Okay, 95%, comma, the degrees of freedom, which is 2, and that's it. 5.99 is our critical value. Now, to compare that, look at, we have 2 as our test statistics and 5 is our critical value. So, and our, 2.8. And our degrees of freedom is 2. So, 2 must be color blue. Should we say color blue, no? 2. So 2 point something is somewhere here. 2.8 is here, somewhere here. But our critical value is 5 somewhere here. Again, our critical value is 5 here. Going to the right is our rejection region. That means if our test statistics is inside the rejection region, which is to the right of 5.99, then we reject the null hypothesis. But this time, our test statistics is 2, is just somewhere here, 2.8. It does not enter the rejection region, or in no-brainer way of thinking, if it is less than the critical value, then we cannot reject. Therefore, we accept the null hypothesis. Another way of thinking so is the p-value. Okay, how to find a p-value? Just use the formula equals chi-sq dot test. Okay, let me delete it in equals chi-sq dot test, type that one, and then highlight the observed and comma the expected. Okay, that's it. That is your p-value. How are you going to write the p-value? That is negative 0.1. So you have 2.46. So you move to the right once. So that must be 0.246. Is that bigger than 0.05 or smaller? So that is smaller. Bigger than 0.05, right? That is 5%, and this one is 24%. So therefore, this is reversed put. Okay, if the p-value is greater than the alpha, that means we accept the null hypothesis. Take note again, or in the opposite side, if the p-value is less than 0.05, for example 0.03, that is, we can reject the null hypothesis. Okay, so how are we going to write it in tables in your research? So you're just going to write the degrees of freedom, which is 2. The computed chi-square now is we have 2.80. Excuse me. The critical value is 5.99, and the p-value is 0.246. Okay, now let us decide on the null hypothesis. Again, how to decide? If we are referring to the chi-square value and critical value, no, you may say, if the chi-square value is greater than the critical value, then we can reject the null hypothesis. But this time, the chi-square value is less than the critical value, therefore we accept the null hypothesis. Okay, the null hypothesis. Okay, that's it. And therefore, the verbal interpretation says that there is no significant difference. Significant difference. Significant difference between the ICT skills and the gender. That's it. Problem solved. That is how you do the chi-square test. Okay. Let us have another example so that you will be directed as to different types of chi-square test. Okay. This one. Another. You have supervisory skills. There are two variables. Supervisory skills versus years in teaching. Okay. We have here the actual. These are the mean. Okay, how to find the mean of the supervisory skills of the respondent number 1. Okay, for example, I have here the actual data. Okay, this is supervisory skills. Okay, should I say students assessment? Okay, 3.78. This is 3.78. For just for instance. So how were we able to do this? So just add. No, example. This is your question number 1. The score is 4. So you just add 4. Example, strongly agree is 4, agree is 3. So you add 4 plus 3 plus 4 plus 4, and so on. Divide it by the total number of questions, and then you will now find your mean. Okay. So the mean here is, let me go back to the another sheet. So the mean here is 3.68 for the respondent number 1. That means, what does it mean? Very good, no? Very good. You have the scoring procedure here. 3.68 belongs to very good supervisory skills among teachers. Okay, teachers are the respondents here. Now, with the years in teaching, the second variable, 28 years. Therefore, she has been teaching, or he or she has been teaching 28 years already, and she has or he has a very good supervisory skills. But there are also 3 years in teaching, yet very good in supervisory skills. So they really vary. Okay, that is why we need to use the chi-square test of independence to see. Again, what is the first step? You are going to construct the table across. Column is for the second variable. The first variable are for the rows. Okay, look at here. Very good. Now let us see. I use here colors so that I can easily identify how many respondents have this scale from 23 to, try to look at the green color. 29 to 34 years of teaching. There are how many? 1, 2, 3, 4, 5. There are 5. Oh, look at here. I got it correct, right? 5. 5 teachers who have 29 to 34 years of teaching experience. But they are split into 2. The 4 are very good, while the 1 respondent is good. Okay, so you know how to tally it. Just use the formula equals count ifs in the previous slides or sheets. Okay, again, tally everything. Go create your expected table. Another for test statistics, and you use the significance level, degrees of freedom, test statistics, p-value, and the critical value, and you are going to write down here the values, and you are ready to go in your research. Now let us identify. Look at here. The test statistics of this is 3.54, while the let's say the critical value is 7.2. What can you say? Yes, this is the test statistics is still less than the critical values. Therefore, we can say it is the null hypothesis is accepted because it does not lapse the critical value. Easy as that. Therefore, how are you going to construct the statement? Therefore, there is no significant difference between the years of teaching and supervisory skills of the teachers. No matter how long or short the teaching experience is, still they are good, very good, in supervisory skills, because most of them have very good and good supervisory skills. That is how you interpret the data. Okay? I hope everything is clear now for the chi-square test of independence. You may move the range, and you may, move the, and go back to the video replay and know how to do it. Okay? Should you have more questions, you may ask or PM me. Okay, thank you so much, and goodbye.